Hello everyone, this is Gautam Reddy Thumalapalli, and today we are going to discuss about a topic called overview of quality tools. In this presentation, we will focus on major points like concept of quality tools, Pareto charts, uses of cause and effect diagrams, and we are also going to discuss the check sheets, etc. Uh, uh, While coming to the total quality tools, the tools that enables the employees to do their jobs effectively for collecting and displaying information in ways to help the human brains grasping thoughts and their ideas. When thoughts and ideas are applied in physical process, the process yield better results such as problem solving or decision making. We can find better solutions and decisions to be also developed. While coming to the Pareto charts, it is very useful tool whenever one needs to separate important information from the trivial information. The chart, first promoted by Dr. Joseph Giron, is named after an Italian economist and sociologist, Vilfredo Pareto. He had the insight to recognize that the real world of minority causes lead to the majority of the problems. Uh, in the and the Pareto principle will usually hold. mm, for example, you can name only about 20% of them will produce 80% of the product defects. 80% of the cost associated with the defects will be assignable to only about 20% of the total number of defect types occurring. For example, we can see the cascade of Pareto charts. In the chart determines the most significant category in the first chart, making a second chart related to only to the category. As shown in figure that starting at the top, we see the following points. In figure 1, miswires. Wires connected to wrong point or not properly attached to the right point. Account of 40% of the remaining rework cost. In figure 2, wires connected with hand wrapping tools represent more than 70% of the all miswires. Of the hand wrap defects, more than 65% are caused by operator error. Of all the operators doing hand wrap work, operators 33 and 28 contribute more than 80% of the defects. While coming to the cause and effect diagram, we normally use a cause and effect diagram to identify that isolate causes of a problem. The technique was developed by the late Dr. Ishikawa, a noted Japanese quality expert. So sometimes the diagram is called Ishikawa diagram and often we call as fishbone diagram. In his book Guide to Quality Control, Ishikawa explains the benefits of use causing and effects diagram as follows. Creating the diagram itself is an enlightening instructive process. Such diagrams focus a group, thereby reducing irrelevant discussions. Such diagrams separates cause from symptoms and force the issues of data collection. For example, the cause and effect diagram for the shoulder defect is a perfect example for this. It presents a picture of the majority factors that can cause shoulder defects, and in turn, the smaller factors that affect the major factors too. Examination of the material dip shows that there are four factors directly affecting materials in regard to shoulder defects. And the parts themselves, the handling of the materials, and the solder and flux used in the process. The chart points out that contamination can affect the soldier's performance, and also the big issues affecting the parts is solderability. In this case, the branches go to the levels from the rib, noting that solderability can be affected by the vendor supplying the parts, storage of the parts before use.
Sheet is a structured, prepared form of collecting and analyzing data. In this check sheets, we will collect all the data where, from where we want, and we will put them in a check sheet, so we easily can divide them and we can calculate what we want and how is it prepared. There are different types of check sheets. Those are tabular check sheets or tally sheets, location check sheets, and graphical or distribution check sheets. This is generic data collection and analysis tool that can be adapted for a wide variety of purposes. By using check sheets, we can use this for a variety of purposes in the different fields. It is considered as one of the 7 basic quality tools. The purpose of this check sheet mainly is to make it easy to collect data for specific purposes and to present it in a way that facilitates conversion from data to useful information. It will convert the data into the useful information in an easy way. This is the example of the check sheet. On the left side, we can see the numbers, the date, and the shaft length on the date. In the right hand side, we can see the check sheet. The left side is just a raw material, but in the right side, we can see the check sheet. We can see the specifications like 1.120 to 1.130. So in this check sheet, the shaft length is on the right over the left, on the right side one. So the out of limits and those are indicated with the star marks. So the whatever we want is in the middle, except those with the marks. And then histograms. Histograms are used to chart frequency of occurrence. The two kinds of data commonly associated with this process: attributes and variables data. Attribute is something that the output. Attribute is dependent on the variable. Variable is the input. The change in the variable makes the change in the output. So if you give something to the input, it will change automatically the output. The different inputs gives us the different output results. We can see the raw data in here as a red beds. We take an example as a red beds and samples with one red bed, two red beds, or overallly we have taken 100 samples. So we can we can take the mean from the whatever we have taken the data in the last slide. So mu is equal to sigma x divided by n, the quantity of the beds and the quantity of the red beds, number of red beds, and we will find the standard deviation using the second formula sigma. Over here, this is the explanation of the histogram, how we calculate standard deviation, and what is the useful of these histograms. And then the scatter diagram. The scatter diagram is used to determine the relationship between the two characteristics or two variables. For example, every day we will drive to the workplace, or we will drive to the college, school, everywhere by car or vehicle. So there is a relation between automobile fuel consumption and the rate of speed, because how much we speed go, the miles per hour or miles per gallon automatically varies with the speed. So to prove or disprove, recorded on a scatter diagram that has miles per gallon on the y-axis and miles per hour on the x-axis, and are the two, and those miles per hour and miles per gallon are the two variables or two characteristics. So there are three types of scatter diagrams, like strong positive correlation, weak negative correlation, no correlation. Strong positive correlation means all the points in the to be considered a strong relation, the data must be tightly grouped in a linear diagram. That means like miles per hour and miles per gallon are almost the same. Weak negative correlation means there is a loose relation, like there is a huge difference in the miles per gallon and miles per hour. No correlation means there is not, we can't even relate both of the in a single way. And I mean, when a pattern has no describable linear component, it is said to be show no correlation. As we can see in the diagram, the first one is a strong positive correlation. As we can see in the diagram, all the points are bound together. And in the second diagram, we can see that there are something like they spread it apart. But
Hi, my name is Sai Kumar. I will be discussing about the run charts, control charts, stratification, and other quality tools. The run chart records the output results of process over time. The concept is strikingly simple, and indeed it has been used throughout the modern times to track performance of everything. For example, we have shown in the given diagram, and the next. The control chart is more sophisticated version of run chart. The run chart records the output results of a process over time. For this reason, the run chart is sometimes called a trend chart. The weakness of run chart is that it does not tell whether the variations in the result of special causes of common. Thus, this weakness gave rise to the control chart. On such a chart, data are plotted just as they are on a run chart, but a lower control limit and upper control limit and a process average are added. The plotted data stay between the upper control limit and lower control limit while varying about the center line or average on only so long as the variation is the result of common causes such as statistical variations. And the third one is stratification. Stratification is a tool used to investigate the cause of a problem by grouping data into categories. Grouping of data by common elements or characteristics makes it easier to understand the data and draw insights from them. Stratification analysis is a quality assurance tool used to sort data, objects, and people into separate and distinct groups. Separation data by stratification can help to determine its meaning, revealing patterns that might not otherwise be visible when it is being lumped together. And the other quality tools, the other quality useful tools are 5S of flowcharts, surveys, failure mode and effect analysis, and design of experiments. And the first one is 5S is used to eliminate waste and reduce errors, defects, and injuries. Now second one is the flowcharts. It is used in a total quality setting for charting the inputs, steps, functions, and outflows of a process to understand more fully how the function works and who or what has input into the influence on the process. And it has more inputs and outputs and even its time. And the third one is the survey. This survey is used to obtain relevant information from sources that otherwise would not be heard from in the context of providing helpful data. And the fourth one is failure mode and effect analysis. It tries to identify all possible product or process failures and uh, prioritize them for elimination according to their risk. And the fifth one is design of experimenting. Is a sophisticated method for experimenting with complex process for the purpose of optimizing them. So finally, let me conclude what we have said. We have described the concept of quality tools, the Pareto charts, uses of cause and effect diagrams, check sheets, the histogram and its uses, and also the scatter diagrams and how they run control charts and the uses of the stratification. So the quality tools are very important for any employee and it can help to analyze and visualize the data thoroughly. Thank you.